everyone, and welcome to today's episode of Seed Speaks. My name is Ashley Robinson. I'm the editor of the Alberta Seed Guide, and I'll be acting as your host for this episode. On today's episode of Seed Speaks, we're taking a closer look at how trait stacking has evolved and what it means for plant breeding. Thank you to Catherine Hatcher, Jeremy Ross, and Michael Dzakovich for joining us today. And to those watching, please don't hesitate to ask any questions you may have for our guests in the chat box. And let's start with getting to know our panelists. So Catherine, can you please tell me a bit about your work at Syngenta?
Good afternoon, Ashley. I am the Southern Market Segment Lead at Syngenta. So my responsibilities are to steward the plant breeding activities for maturities group 4 to 7.
Thank you. And Jeremy, can you tell me a bit more about your research work at the University of Arkansas?
Sure. I'm the soybean agronomist with the University of Arkansas System Division of Agriculture and the Cooperative Extension Service. And so I do a lot of, agronomic research, looking at, seeding rates and row spacings and looking at different products that soybeans that farmers are being asked to use on soybeans. And so but also, work with the weed scientists, entomologists, plant pathologists, soil fertility here in the state, along with doing some regional and national work as well.
Thanks. And Michael, can you tell me about your work at the USDA? Just a second there, Michael, you're muted.
Okay, there we go. Thank you so much, and appreciate the invitation having me on today. I'm a research plant physiologist with the Agriculture Research Service, and I'm located at the Children's Nutrition Research Center. And so my research and everyone in this center, their research is focused on improving the health and well-being of children and mothers. And so in my lab in particular, we use both genetic tools and environmental tools to improve the nutritional quality of the foods that we eat.
Thank you. I think we got a really good group together here today. We should have a really good conversation. So let's start with some questions. So Jeremy, I'm going to ask you a question first. Does multi-trait stacking help to fight weed issues in soybeans?
Absolutely. So, we've been looking at genetically modified, seed since the mid to late 90s. And so, with the introduction of Roundup Ready soybeans, we've seen multiple stacks, so especially over the last 10 or 15 years, looking at the addition of different herbicides to help combat, some of the more problematic weed issues, especially we have here in the Mid-South. And so the number one weed issue we have to fight is glyphosate resistant palmer amaranth, and so, or pigweed. And so with these stacked traits, we're able to control that particular weed along with some of the other weeds that we have in our Midwest and our Mid-South soybean production. And so without those traits and being stacked, we wouldn't be able to control some of these more problematic weeds. And so, I think, in the future and what we're looking at, is just to continue to add more and more traits, on soybeans. We really haven't seen the stacking of, some of the BT or some of the, traits against some of our more problematic, insect diseases like we've had in, corn and cotton. But, the main thing, we've been looking at, with soybeans is the stacking of our weed herbicides.
Thank you. And Catherine, of course, you also work with soybeans. So what are some of the instances where you've worked with multi-track stacking and how has it helped?
Yeah, thanks for the question. So one thing I think to point out is trait stacking is not a new way of working for plant breeders. We just have these newer traits like Jeremy mentioned. So one of the ways that we want growers to be successful, of course, is to realize yield in the combine. And to do that, we combine maturity traits with things like standability so that the crop will be easy to harvest, disease traits, native traits. So the soybean germplasm has, say, tolerance to sudden death syndrome. So you ensure that you make combinations of parents that provide you with varieties that have those disease traits, pest tolerance, and then incorporating those tools so that growers can use different herbicides to control weeds so that they can be successful. So we use all of those tools together to be able to provide a product portfolio on the variety side, to give growers choice and to hopefully make sure that they're successful when they get that bag at the farm.
Thanks, Catherine. And of course, Michael, you have a bit different focus in your work there. So can we talk a bit about how trade stacking in crops such as sorghum can help to fight hunger?
Sure. Yeah. I mean, and kind of looking big picture. Again, I'm looking more at the nutritional side of things. But when we think of nutrition, nutrition is really complicated. I mean, we think, we've got our macronutrients, carbs, proteins, and fats, but then there's also dozens of vitamins and minerals and other micronutrients that we need to be healthy and well. What ends up happening is that in situations where people are food insecure, more often than not, you'll have multiple nutritional deficiencies happening at the same time. And so with trait stacking, what that allows us to do is potentially address multiple nutritional deficiencies at the same time. Similar to bringing in, different types of resistance to pests or weeds, you can bring in genes to help fight many different issues at the same exact time.
That's really cool. And of course, it's one of those things I know whenever I talk to plant breeders, there's so many things to think of. Yes, if when you're looking at from the farmer standpoint, you're like, okay, yield. But then you also have to look from the consumer standpoint and being able to get because if we grow something and then it's not good for anything, like it's not going to help anyone anywhere, then why are we growing it? Why are we breeding it to begin with? So my next question is just a general question for anyone who feels like answering it. Why is multi-trait stacking in demand for plant breeding? Like what really is it helping us to be able to do there?
I think it helps us maintain a stable source of food, whether it's for people or for our animals that we love. And trait stacking allows us to grow that particular variety, be it soybeans or sorghum or corn, in that environment. The environment is ever changing. And so we have to provide plants that have the genes that can thrive in that environment. And so it provides that stability. And then, like to Jeremy's point, is it the amino acid profile that you want so that you can provide that amino acid to combat those issues with deficiencies? So for me, it's stability is really important, and then quality and volume.
Definitely.
Yeah.
Michael, what do you want to add to that in regards to, of course?
Yeah, I think that's a perfect jumping off point because, like I said, there's many different, in terms of nutrition, there's many different issues that can happen in terms of the quality of our food. But just like Catherine said, I mean, quantity is also a big part of it, just the availability of food. So having the ability to not only have high quality food, but also have reliable food sources in increasingly harsh environments.
Definitely. And Jeremy, is there something you'd like to add more on the agronomic side when we're looking at that?
Well, if you're looking at soybeans, kind of the end use, and so we've got some that have different oil profiles or high protein that are being used for animal feed or things like that. And so, as Catherine mentioned, it's not just the non-native genes that we're being able to stack. It's some of the from exotic soybeans or maize or something like that. And so I think Catherine kind of hit it on the head that it's really kind of the environment you're trying to grow these in, and what genes do you need to have to really maximize the yield in these different environments.
Yeah, definitely. And I think that feeds into my next question, which is kind of looking at where do you guys see opportunities when it comes to trade stacking, and what kind of problems could we solve by introducing new traits to crops? So I think I'll let Jeremy answer there first, because I feel like he was really leading off onto that.
Yeah, and then if you're especially looking at soybeans, again, it's kind of going back to what our end use is. We're looking for sustainability. Still having a big push in biodiesel, and so we can kind of maybe increase the oil content of our soybeans a little bit more to gain a little bit more out of that. But there's becoming more and more different end products. And so if we can kind of, modify, some of our amino acid profiles and different things like that, our protein or oil content to kind of gear it toward, kind of what your specific end goal is going to be. Maybe we can kind of, you know, look at these niche markets and kind of have, customized, soybeans to really kind of fit into some of these niche markets.
Yeah, definitely.
Yeah, and I guess kind of,
Michael, please go.
I was just going to kind of jump off of one of Jeremy's previous points, because he was mentioning how sometimes, you don't even have to bring in genes from other organisms. You can simply use trait stacking as a way to take traits that you want from the same organism and bring them together in the same situation. And so with your question of, what are some of the big opportunities with trait stacking? I really feel like there's a lot of opportunities to, in cases where we don't have that natural diversity present for the traits that we want, we can kind of create that diversity and solve some of these challenging problems that we have to deal with right now.
Definitely. And Catherine, is there anything else you'd like to add there?
Yes, just I actually wrote sustainability right before Jeremy mentioned it, and the opportunities are there to explore our diversity of germplasm. So in all crops we have relatives, we have other species we can utilize, and I can give an example. For example, where numerous growers are now using water use efficiency corn, for example, so you can grow the same amount of food in drought environments. So opportunities like that lie for other crops. Soybean is one that we try to produce more yield with fewer resources and take care of the environment, because sustainability is a major goal for most plant breeding programs.
Thanks. And of course, when we're looking at plant breeding, everything, every crop has such a different genome. So when we're looking at stacking traits, are there any crops that it's harder to do in?
Yeah, I can probably try to take that. Tree crops are really challenging to breed. They have a long life cycle. So it takes you a while to develop the population and be able to test it. So it presents the breeder with more challenges, and so they have to be more use more ingenuity. They have to leverage other tree crops. So you can look at the pan genome, many genomes put together, and try to learn from what exists in other crops. So you're not literally reinventing the wheel each time.
Yeah, it's super interesting. Jeremy or Michael, do you have anything to add?
No, I don't. I mean, I think Catherine's probably the expert in our group
Definitely.
on answering that question. So
yeah, it's definitely a challenge, but I think there's a lot of opportunity. The breeding communities get together a lot to learn from each other, use new techniques like machine learning to model out different scenarios, so that you're hopefully trying to stay ahead of that changing environment and make sure that we are providing our growers with successful tools.
Mm-hmm. And I think that leads
I
think that leads really good into an audience question that we just got from Alex Hahn. And she's asking, do stack traits take any longer to breed for than traditional varieties? And then there's another question on the end there. Do you think we'll be seeing more of a demand for stack traits? So maybe first off, I'll direct it towards Catherine, and then because I can see her thinking on it, if she wants to answer, and then we can have anyone else jump in.
I wouldn't say that stacking traits lengthens the crop cycle, and the reason for that is we've been stacking traits, as I said, for a long time. So there is really not that difference in what folks would call traditional breeding. Again, traits like yield, for example, are extremely complex. Many genes contribute to yield. So what might take longer is testing phases, and the way we try to ensure that we can speed up that process is testing in multiple environments at the same time, so that when you collect the data together, we can make that decision a lot faster.
Definitely. Is there anything that Jeremy or Michael like to add?
I guess, kind of jumping off, the testing cycle, I suppose, depending on the way that the trait stacking is being done, certainly there's the regulatory aspect to it as well. So, I guess if you're considering traditional breeding as like, marker assisted selection, depending on the regulatory landscape that you have to go through, depending on the way that you're creating that crop, that could probably take the most time, I would imagine.
And I'll address, the second part. I mean, I think, yeah, I mean, from here on out, all we're probably going to see is more and more stacked traits, and not necessarily GMO stacked traits, but as Catherine mentioned, breeders have been stacking traits for years, and as the demand for more, food to feed the population, we're just going to have to, look at yield traits and different things, to protect, what crops we have out there. And, we're not getting any more land. And so we're going to have to, grow more and more crops on, what land we have. And we're just going to have to increase that. And so I think, the breeders and people like Catherine are, looking at, just all kinds of different things that we can add to the genome of our, row crops and other crops to try to produce a high yielding crop, or to feed the population.
Yeah, and you guys have touched on this a bit, really about that technology aspect. So, of course, we have seen trait stacking happening for a while. It's not some new fandangled breeding technique, but there's a lot of new technologies out when it comes to breeding. So, are there any of those new technologies that could be used to enhance or work with trait stacking? Anyone feel like tackling it first? Promise I don't bite.
I mean, I guess I think Catherine looked like she was cooking up an answer there, but certainly I think one of the exciting things that's been, kind of making some of the news cycles in the last few years is, gene editing technologies like CRISPR-Cas9. That's certainly something that's kind of been emerging and becoming a little bit more utilized by breeders and basic scientists alike. So I think, and again, gene editing has been around for a while with different techniques like talons, for example. But I certainly think that other technologies and improvements on that technology are going to become a big part of what's being used to actually conduct these trait stacking experiments.
Definitely. And Catherine, is there anything that you've thought up there?
That's a fair answer from Michael. I think research in the public and private spaces comes up with new tools actually quite often, and depending on the goals of the program and the availability, and I think we mentioned regulatory earlier, that we follow all of those requirements, and where possible we will use different techniques to accelerate the pipeline.
Definitely. And Jeremy, is there anything else you'd like to add there?
Well, I work with our local breeders and others in the, other universities. And so it, they start talking about CRISPR and some of these other things, and it kind of gets over my head pretty quick, but it's exciting to see, at least new techniques and, different things and, procedures trying to speed up, the breeding process. And, because, conventional soybeans, back in the day, it may have taken a breeder, 8-10 years to release a variety. And so now we're seeing that at least maybe cut in half, and potentially, a little bit quicker. And so I think, these newer techniques, as Michael mentioned with CRISPR and some of these other things, I think is just going to be able to speed up the process and be able to get varieties out at a quicker rate.
Definitely. And when we are looking at that future, what's next for multi-trade stacking? What gets you guys excited, or what do you think we could do? I'll start with you, Jeremy.
Well, there's here in the mid South, I mean, there's insect issues that we have to deal with. There's drought issues. We have other characteristics, chloride problems, and so I know our breeders in the mid South are looking at some of these more problematic issues that farmers are facing. But it's I think the future is wide open on some of these things that we're going to look at. But at the top of my head, I think insect would probably be the first one for the mid South is what we kind of be looking at.
And Michael, but what about with you?
One of the things that I think about a lot, so I work with a lot of specialty vegetable crops, and so, like let's say, spinach, for example, like leafy greens, and, thinking about the future and in terms of resource limitations that we might run into, one of the things that I'm kind of looking forward to on the horizon is seeing this rise of breeding programs that are focused on developing cultivars that are suited for controlled environment agriculture, which I think is increasingly becoming a more and more prominent part of our food system. So I think, in the lens of trade stacking, I think that could become a more efficient way to, better utilize crops to work within those more artificial environments that they're, kind of not used to.
Thanks. And Catherine, what about with you?
Yeah, I can just sound on both of those topics, and my vision is to look at the relatives of the crops that we're breeding for. A lot of that untapped sources of disease tolerance to either pests or pests and diseases, and then of course coupling that with the tools that we already have to combat like weeds. And so just looking at the diversity and just tapping that, because cultivated crops are very special, right? They're focused on very narrow objectives, whereas our wild relatives have been combating the environment for a long time. So leveraging that is a very powerful source for us to continue to be successful.
Definitely. I think you guys really touched on a lot of good stuff there. There is a lot of opportunities. It's just kind of figuring out where you want to go, because really the world's your oyster when it comes to this stuff with all the technological advances that we're seeing in plant breeding right now. It's amazing what we can do now compared to even just 10 years ago. I'm sure if we went back and told our ancestors 100 years ago what we're doing now, they'd probably drop over dead. So anyway, that is all the time we have for today. So thank you, Catherine, Jeremy, and Michael for being here. I really enjoyed the conversation, and I know I learned a lot myself. And for those watching, thank you so much for tuning in. And if you missed part of today's live stream, don't worry about it. We'll have it available on demand on Facebook, YouTube, and LinkedIn. And if you have any questions about the subject or ideas for future topics, please feel free to reach out to us via the Seed World Facebook page or our emails, which are found on our websites. And next week, we have a really exciting week because it is time for a new season. So we'll release the trailer for our new season, and you'll find out what our next topic is. And thanks so much to everyone for tuning in today, and have a great rest of your day.